So I have posted, today is Tuesday, and we're going to do nomenclature, but we're going to do it with a twist. And I hope that you find this puzzle to be fun. So download a periodic table, the list of elements, and then the worksheet. And our goal is to work through the worksheet. And this is to get us ready for when we do nomenclature on the test this week. When we do nomenclature on the test, I needed to find a way that people couldn't just Google answers, because that is happening. Not you. I'm just saying there's some students, there are quite a few students that are Googling, and it's not good for them. And so I needed to find a way around that. And that's what we're going to practice today, is how to use this new periodic table. And then if you don't feel comfortable after one day of practicing it, we will do it again until you're comfortable. Okay, so as people are coming in, I want to tell you a story. Once upon a time, there was a student in her 20s that wanted to learn to speak French. And so she took a French class at night offered by Sierra College as she worked during the day as an elementary school teacher. Yes, this story is about me. So I was in my third year of teaching elementary school, and I took this French class, and it was a 3A, 3B actually. It maybe didn't have those numbers, but it was kind of like first semester French broken up over a year. And we were in the second semester, and there were maybe, I don't know, 15 of us that had made it to the second semester. And we're still interested in still taking it. One of the students in the class was this man who was probably the age I am now. But at the time I thought, what is this old man doing in the class? And he kind of spoke with a twang, and he was lanky and a little bit awkward. And, you know, I was young in 20s and thought I had the world on a string. Anyway, the teacher gave us an assignment, and the assignment was this. And we had to write this page in French. Are you a good student? Explain why or why not. And back then, my brain was really quick. And I have an ear for languages. And even though I hadn't taken French, because I had a degree in voice, I had taken French diction. Like I could speak. I didn't know what I was saying, but I could say the words right. And so I wrote, in French, I am a good student because I learn quickly, and when I say things, they sound right. Like those kind of sentences. And at some point I thought, I wonder what he wrote. And then as I continued in the class, and as I continued to be a teacher, I'm getting teary now, I realized, I hope that he wrote he was a good student, because he was a better student than I was. And he probably wasn't getting an A, and he probably didn't care, because he was there to learn. He had his reasons for being there. And he would say, Asha, a cat, and then he'd go, and Sha, and then she, who had studied French in Paris, would correct him. She was the most teacher ever. Like I learned a lot from her. And then she would say it, and then he would say it, and then she would say it, and then he would say it. And like it just, you could just hear it didn't sound the same. But he came every time prepared. He wasn't naturally good at this, but he tried his best. And he was a great student. And so I just want to say to you, you great students sitting in front of me, you're coming, you're prepared, you're doing your best. And if you can't pronounce the words properly, that's okay. Someday you will. And I have been blessed / cursed with being a quick learner, especially when I was younger. I've killed a lot of brain cells since then, so really slowed down, but for the people who learn more slowly, you're digesting as you learn, and that's actually a better thing. So just to you that are bright and lazy, I would admonish and encourage you. Oh, here's another thing he did. He was good with everybody in the class. Like I was there for me, but he was there for him and the whole community. And he did it very quietly, but he definitely was a team player. But anyway, so I would admonish the bright, lazy students who feel good because they get A's. There's nothing wrong with being bright and getting A's, but being lazy is not going to help you. And you're going to come to a place where that's not going to serve you well. So why don't you start working now? And then to the students that really apply themselves and sometimes feel like it just doesn't pay off. And then you look at, you're the tortoise and you look at the hare next to you and you're like, oh my gosh, I will never be that person. Be glad you will never be that person, because their gift comes with a curse. And if you are a person that just works and works and works, you will get to the end of the race. And it'll be good. So I posted what we're about to do. I posted on Facebook. I have a lot of former students that are Facebook friends. And I said, here's my periodic table. I'm just so sick of the cheating. And they're like, that's brilliant. You can test nomenclature without, the benefit of Google. And then one of my students who's currently at Davis, she's a senior. And so I had her probably 3 years ago in Chem 3A, 3B, and 1B. She said, good for you, Sue, because the students will appreciate this later. And my thought was, some of them are going to drop, and some of them are going to hate me or hate me for a while, but here we are. And my response to her was, I hope so. I am really doing it because I think it's what's best for them. So to make a short story long, it is my gift. Good for you for being here. I'm proud of you for being here. And now's the time to get scrappy, because now when people start to be comfortable in the class, and the people who haven't been doing the work are going to start to fall away. And if you're one of those people that's hanging by your fingernails on the edge, you're standing at the precipice looking at maybe dropping, especially after you take this next test, I would encourage you don't. Just find a new gear. Learn to work. How are you going to do that? I don't know. I suggest that you talk to your peers. And when you talk to your peers, they'll have ideas. And some ideas will be good and some won't for you. Like, it may not fit you, but that's okay. I suggest you get scrappy. Okay, so what we're about to do, also I've taken a turn in my teaching. I just need you to know that. I think you probably can sense it. I realized I can't save every starfish. This online environment does not allow me to walk up to you and to engage you and to start a conversation with you. And so not you, I think the people who are here now, but keep in mind I'm recording this for the people who should watch later. Some of you aren't going to make it, but that's your choice. You can choose now to turn a different direction, to step up. But I'm going to stop losing sleep over the ones I can't get. And I'm going to invest in the ones that are present. And so that's you. Okay, here we go. I hope you like this. I hope it's fun. Okay, so you're familiar with the periodic table of elements. It's like such an important tool in chemistry. And we've talked about nomenclature for a couple weeks. And at this point, some of you are pretty good at it. And some of you have been taking a shortcut, and it's going to show real quick. But you can still step back, because in Chem 3A, we have time to go back and relearn things. I have time to reteach. I am happy to give a whole nomenclature package spiel to one of you, or a group of 5, or 30 of you, if you want that, but you have to ask, because I can't see your faces, and I don't know who's engaged and who's not. But anyway, so you've learned nomenclature, and now we're going to see how well you know it. So I want to remind you of some things that you know. You know that the main group elements are groups 1 through 8. And you know that these main group and representative elements, when they form ions to become more stable, they have a certain charge. There's a tendency. And so for group 1, those atoms lose 1 electron to have a +1 charge. You lose something negative, you become more positive. And so if one of these metals here, hydrogen, not a metal, loses an electron to become more stable, it has a +1 charge. If one of these metals in group 2, the alkaline earth metals, lose electrons, because metals lose electrons, metals are easily oxidized to become more stable, they have a +2 charge. Group 3, which is really just a few of these, really it's aluminum for us, +3. And then non-metals have 2 ways to become stable. And one way to become stable is by gaining electrons to form ides. Like a halogen, say maybe fluorine, can gain 1 electron to become fluoride. And a group 6 nonmetal, like maybe, oops, again, sulfur, can gain 2 electrons to become sulfide. So one way to become stable for a nonmetal is to gain electrons, and when they do, the name changes to IDE. But they have a second way, which is to be covalent, which is to share electrons. Who do they share electrons with? With other nonmetals and metalloids. So you're familiar with this. And then the next thing I would say that's going to be important for what we do today is that there is this group in the unknown zone that we have to state the charge because there's more than one charge choice for transition metals. Now, in reality, if it's silver, zinc, and cadmium, you know what the charges are, they're fixed. But for the game we're going to play, if it's in the transition metal area, it has variable charges. And so I have made a periodic table for you, and I didn't know what to pick. If somebody has an opinion about this, I can change it to something else, but I picked pets. So this is the periodic table of dogs and cats. And we have dogs acting as metals and cats acting as nonmetals. And then, so if the things that are in group 1, so bellium, rhocium, barium, and terbium, if they form ions, they lose electrons like metals do, and they have a 1+ charge. Things in group 2, butyrium, lolium, I guess Lola is a popular dog name, mollium, if they form ions to participate in ionic bonding, they have a +2 charge. And then things in group 3, like aluminum, but here we have daisium and maxium, they would form 3+ ions. So metals, which are red here, just like they were the first week of our class, lose electrons to become stable. The ones here in the unknown zone, we're going to have to state the charge. And so we're going to have to state the charge by putting it in Roman numerals inside parentheses. You know, romonium 2, romonium 3, romonium, 4. You're going to have to state what the charge is for Romeo and Jack.
Sue, are those the possible charges for romonium? Are you saying that those? Yeah.
No, I'm just saying state the charges like you would state the charges, and just accept any charges possible.
Okay.
Okay. So nonmetals. Oh my gosh, I just lost my charges, but I think you know what's going on. So these guys aren't going to participate in bonding because they're behaving in group 8, like group 8 elements would. They're noble gases. But halides could be -1, -2, or -3. And then if something like Oliver gains 2 electrons to become stable, it might be olivide. Because when it gains electrons to become stable, the ending of the name changes. For actual elements, you know, there's a certain way things change and our ear bends to it. And so we're familiar with it. But let's say that you didn't know, and on the test, you put olivaride. I know you're trying to apply the rule correctly. It's like phosphoric acid. Oh, you're so sweet. You're just learning. You mean phosphoric acid. Like I will know you applied the rule correctly. So spelling doesn't quite count here. Okay, and then the next thing is, you know that there are line leaders, and the line leaders kind of give us an idea of what's happening in that group. So for this group, Tiger is the line leader. And if we have this, let's say that you encountered MiO3, 2-, and it might be because it's connected to 2 +1 ions. You didn't memorize the 8 for Milo, but you do understand what the line leader is doing. And so this would be Milo 8, and that would be bellium Milo 8. So right now, I imagine, but I'm just imagining, I can't see all these names. I can't see your faces, so I have no idea. That some of you are probably frustrated and you're thinking, what on the tech, really? You're going to do this? Like we're going through the stages of grief. Anger, bargaining, depression, sadness, denial, and then we come to acceptance. And I need you to get to acceptance before you take the test. There are reasons that I have to do this. And so I came up with the table last night. And then I realized, oh, actually, this reinforces naming. And a bunch of my former students on Facebook were like, yes. So people who are a little farther down the road than you think this is good. Now, you don't have to agree with them. Like, just don't drop the class. Stick with it. You're here now. Keep trying. And we'll see how this goes. Okay, so far, I'm really just talking about the normal nomenclature things, like how to apply the rules and what derivatives are. And if you want me to go through this at another time with the actual nomenclature packet, I can do that. I just won't have time tonight. That's totally fine. Okay, so Tiger 8 is the line leader for group 4. For group 5, it's going to be Callie. When you see the 8 ending, that tells you it has oxygens. 8s and ites contain oxygens, and ides don't. So we need a line leader, and we need to be told what the polyatomic is. So I'm telling you right here, Calliate is CaO 3-. So if we go down the line, we could go to smoky 8 or Leo 8. Just take those words and add an 8 to them, and they would have the same charge. So smoky 8 or smoke 8 is below Callie, and Callie 8 is CaO4 3-, and smoky is SM. So the SM, same number of oxygens, same charge. That would be smoky 8. If the charge is greater than -1, it is possible to add a hydrogen and still have an ion. So do you know the formula for hydrogen smoke 8 or smoky 8? There's only one more step. Does the O in polyatomics represent oxygen or Oliver? Oh, yeah. In this case, oxygen. I'm just observing for now. And why did you add an 8 to smoke 8? Oh, because it's oxygen containing. So right here, when I, let's see. So anytime it ends in 8 or ite, that means we have the nonmetal with some oxygens and extra electrons. If it ends in ide, the nonmetal has just gained electrons but no oxygens, which is how it is actually in nomenclature. Everything I've done here is following the regular rules of nomenclature. So what I'm doing right here is we're just going to do naming. And we might be naming an ionic compound or covalent. So we're only naming compounds, and it'll be very clear when we're using this table and when we're naming compounds. I will give an assignment because some people won't be here at Zoom and won't watch the Zoom, and I don't want them to be a deer caught in the headlights. I need them to know this is coming. So I will make an assignment, and it will have a key that I'll post under keys. It's basically what we're doing tonight. I might just make copies of my page. I've already done the key. And then when you take the exam, there'll be 2 parts. So tomorrow when we go into, this is week 8, it'll say for this week's exam, there's two parts. There's the regular exam, and then that doesn't include nomenclature, and then there's nomenclature. And when we do nomenclature, it's going to be using the periodic table, this weird table, and then it'll be limited to naming ionic or covalent compounds. So it'll be very clear that one half of the exam, which is nomenclature, is this silly table. And for this silly table, we will only name ionic or covalent compounds. There are two kinds of ionic compounds. There are fixed charges, and there are variable charges. And then for the fixed charges, it's going to be what it would be on the regular periodic table. So fixed charges means we're talking about the representative elements. And here they are, +1, +2, +3. For variable, we're talking about the ones in the transition metal area where you have to state the charge. And then if you have a nonmetal plus electrons, that makes an ide. So buide would just be bu gaining electrons to be like charlium. How many electrons does it need to gain? 1. Kidide or kittiide would be K, because that's a symbol, but because it's in this column, it'd be -2. And then if we had leoide, it would need to gain 3 electrons. Now for the for the ionic compounds, we're going to be combining cation plus anion. The anions could be ides or ates or ites. So for the anions, you can have an ide, just gain electrons to be like a noble gas, that kind of thing. Or ates, we're limiting our ates to this set of 4. They're the line leaders. Or ites. And the ites are like the ates, but 1 oxygen fewer. So if scampate is SCO3 1-, scampite is SCO2 1 oxygen fewer, same charge, 1-. There are some derivatives we need to be able to do for these 3. Because the charge is 2- or 3-, you can gain 1 hydrogen and still have an ion. So we are going to have hydrogen containing. That's a derivative. So just like for carbonate, we would have CO3 2-. Hydrogen carbonate is add a hydrogen and change the charge by 1. And the hydrogens are actually hydrogens. H is for hydrogen. That's one kind of derivative. The next kind of derivative is the going down a row thing. Going down a column thing. If I know leucate, LuO4 2-, I also know kidate or kittiate. Same number of oxygen, same charge. And if I know an 8, I know it's ite. Okay, so some people have just joined us, and they may be wondering, what is going on? We're just looking at nomenclature from a different direction. And spelling doesn't count. I'm just looking to see, do you understand the rules and how to apply them? The other thing maybe causing some anxiety would be, oh my gosh, I'm going to be doing this so slowly. The test, that is the nomenclature half of the test, it will literally be, it could be as few as 10, but that makes each one worth more points, and you'll get an hour to do it. So I'm separating the nomenclature from the rest of the test because I don't want anybody to freak out about applying the rules of nomenclature to this new table. Okay, so hydrogen containing, and then things in a column behave the same. I'm going to say group 8s. Like I know carbonate, so I know silicate. I know chlorate, so I know bromate, so I know iodate, that group idea. And then we also understand how ites work, 1 oxygen fewer. Those are the derivatives that I expect you'll be able to do. Okay, I want to talk about covalent compounds just for a minute, unless you have something else you want to say. Okay. Something else you want to say? Anything you want to say? For covalent compounds, normally we would have some things that contain hydrogens, like a hydrogen gas, a hydrogen common name, a hydrogen that's an acid. We're not going to have that this time. I really am just doing how many of what kind. We're only going to do like dinitrogen tetroxide, that kind of covalent compound. How many of each kind? Which means you're going to be using your Greek prefixes for any covalent compound. How will you know it's a covalent compound? If you have all nonmetals. Oh, those aren't going to do anything. They're noble gases. And then you say how many of each kind. Okay, so the best way to do this is probably just to get started. Here I have, okay, so what I've done is I've made Jamboards, and I know Jamboards aren't real popular with you all, you made that clear, but here I have your periodic table. I know you probably have one on your desk right now, or on your computer, your device somewhere, but I just wanted to have one as reference, so you could point to it if you need to with the group. And then here are the problems, and then I have worked out the problems. So I was thinking, what if I gave you 10 minutes to work on this, and then we all came back to the main room and we talked about, like, sorted out, do I do this or does this mean that? And I'm like, yes or no, yes or no. And then you go back out to your groups for 10 minutes, because I think it will be useful for you to wrestle with it. And then we all come back together and talk about what just happened. And then with some new information, you go back out and you wrestle with it some more. So for number 1, because it starts with a metal, and there's no oxygens here for the second half, it's just going to be the metal's name. And then I take scamps. Yeah, scamps. And I take off something and put an "ide." But if you have scampsite, it's totally fine. Okay, the next one, MOST2. I'm looking for MO, and expecting it to be on the left, and I find it, mollium. So we have an ionic compound. I'm going to name the element's name first, just like it's written. And there's no oxygens here, so it's just SC, whatever that is. That's scamps has -1, and mollium's in the +2 column. That makes sense. Mollium scampide. Okay, and then I get to one where element on the left. I take it back. If you want to be unmuted, I mean, if you want to mute us, feel free to mute. Everybody mute. Okay, so now I have one that's romeomium. I know that it's a metal because it's red on my periodic table, and so I have an ionic compound because there's a metal on the left. I just say the metal's first name, but because it's in the unknown zone, I'm going to put some parentheses there to remind me I need to state the charge. And then I find B, bu. And because it's an ionic compound, we add the ide ending. So for all of these answers, it's going to be an ide, ate, or ite that ends the second word. And it can only be an ate or an ite if there's an oxygen in it. Okay, so bu is -1, and there's 2 of them. Romeomium must be +2. Romeum 2 Bromium tubuide. Okay, so I'm just working down the chart like that. Eventually you're going to get to something where the thing you're looking for, it isn't on the left. So I'm at like maybe number 9, MiK4. Well, Mi isn't a nonmetal, and that's why you have the list of the elements and their names. If you want me to make that list so it also has the symbols in alphabetical order, I can give you both of those, totally fine. But now I have a nonmetal and a nonmetal. And for this exercise, we're just going to say how many of each kind, but we don't use mono on the first. Just like we don't say mono carbon dioxide. We just say carbon dioxide. So Mi is for Milo. And then I have 4 tetra. And K stands for kitty. But I don't say kitty. I say kitide or kitty-eyed. So the ending is either an "ide" or an "ate." When is it an "ate" or an "ite"? When it contains oxygen. Does anybody want me to do any of the particular ones, 1 through 10? Here's the formula, give a name.
Could you do number 6?
Sure. Okay, so the first thing I notice is, ooh, this is going to be an 8 or an "ite." Let me go down to my table, and I see that chalate is a thing. And then I notice it has a hydrogen, and hydrogen is a nonmetal, even though it hangs out on the left on the periodic table. So this is a hydrogen something. So if I added a hydrogen to that, this charge would change by 1. And what is J? J is for Jackium, and this is it's variable, so I have to put in parentheses. But if there's one of these to one of those, it must be Jackium 1. It was a -3, so this is a -2, so that's a Jackium 2. So because there's a metal on the left, we use the metal name. We don't change that name. Let's see, chats. Number 8, number 7, and 20, yes. And then hydrogen caliate. Catherine, Zeta, space, not hyphenated, Jones. 2 last names. Did that answer your question?
Yep, thank you.
Yeah. Okay, and then the next one was, can you do 8? Yes. Okay, so I'm looking for the element on the left, thinking it's probably a metal. It's definitely on the left on the periodic table. And then it wasn't, it's a nonmetal. So since this is a nonmetal, I'm gonna have to say how many of each kind. So di something, tri something. So di and tri. Now for the first one, Lu stands for Lucy. We give it the element name. The one on the left is given the element name, whether it's an ionic or covalent compound. So dilucy. Tri, and then scamps is on the right, so it's going to get the "ide" ending, scampide. Or scampside, or however you spell it.
A quick question regarding the last one you did, Jackium hydrogen calide or calate or whatever. Shouldn't you put the charge?
Yes,
Jackium?
Madison, you're right. I would have gotten that wrong.
Just making sure.
No, thank you. I'm glad you said that. Okay, so I was asked in the chat to do 8, and now I'm going to do 7, and then I'm going to do 20. Can I clear this board?
Hey, Sue, I had a quick question.
Yeah.
I don't know if I have it right, but the only time that you use the Greek prefixes, is that only when they're nonmetals?
Yes.
Okay.
And then if we had a real periodic table, I would say only if they're nonmetals or metalloids.
Or metalloids. Okay, thank you.
Yeah, you're welcome. No, that's a good question.
And that's for both of the elements, right? If they're both nonmetals or metalloids.
Right, right. Okay, so the element on the left is the one that would be on the left on the periodic table. And if it's on the, when you look at the element on the left in the formula, whoops, I just erased that. That's not what I meant to do. You look to decide, is that a metal? And if it's a metal, it's ionic. But if it's a non-metal or a metalloid, it's covalent. Okay, the next one, number 7, you say. So the first thing I'm doing is looking to see the one on the left. What are you? And so I look for Da, and I expect it to be a metal, because usually there's metals on the left, but it will definitely be to the left of all this business. I find dasium. And I see that it's in column 3, which means this is a +3, so we have a +6 charge total there. And then the one on the right contains oxygen, so I know it's an 8 or an ite. Lu-O42 minus is an 8. That is leucate. Okay. And then I'm just checking. I have a 2 minus here, and there's 3 of them. So this is +6 to -6. We're good. Dasium leucate. And then I was also asked about number 20. Tobium hydrogen callite. Okay, so I have an ite, which means find the 8, and it'll be 1 oxygen fewer. So I'm going to do a little logic puzzle here. I look for callate, and I see CaO4 3 minus. And or callate. And then I look for 1 oxygen fewer would be the ite. Oops. But it's a hydrogen callite, which means I need to add a hydrogen to that. And that's going to change the charge by 1. Okay, and then what about tobium? I find tobium, it's in group 1, so it's a +1 fixed charge cation, so I don't need to say tobium 1. Okay, so I have some of this and some of that. And when I put the +1 with the -2, I see I'm going to need 2 of them. And I don't need parentheses because I only need 1 of my oxyanion.
Can you write it up higher? The bar on this thing is kind of covering it up.
Yeah.
Sorry.
No, please don't say sorry. I want to give you what you need and want. Like, I want to serve you well. That's part of my frustration. You know, in Beauty and the Beast, about the servants who aren't serving and how sad they are. That's how I feel as a teacher this semester. So, okay, are there other ones that you would want me to do? I don't need to do them all. I do have a key. I can post my key. I'll post it before I go to bed tonight, and you can check them under keys.
Could you do 14?
Sure. Rhomonium-3 ketide. Oh my gosh, I'm starting to memorize my periodic table. Ketide's a -1, right? Oh no, it's a -2. No, clearly I haven't memorized it yet. So it's an ide. I know it doesn't have any oxygens. I find it on the table. I see it's in group 6. That tells me add 2 electrons. And then rhomium is a 3. I know that because the charge is stated. So I'm going to have to shoot for 6. I need 2 of these and 3 of these. And the one that is named first is written first. And that's my answer.
Thank you.
You're welcome.